Right, hi student, this is the revision package for WA1. The chapters will be doing quadratic functions and quadratic inequalities. Right, let's look at the basic questions. So the first question is to find the range of values of x for the quadratic inequalities shown, and then we ask to represent the answer on the number line. Right, so to expand this guy here, right, we'll be using the algebraic identities. Right, so A will be your, this is your A, this guy is your B. Okay, so we're going to substitute into your algebraic identities. Right, and then we're going to simplify, bring everything to the left hand side. And if you were to look at it carefully, you can actually factorize 4 out. Alright, so you're going to divide 4 on both sides. And because you're dividing with a positive number, you don't have to change the inequality sign. Right, so you end up getting just x squared minus 3x plus 2, which is a quadratic expression, and then you can factorize it into the 2 linear factors. Now remember, this is a quadratic inequality, so you can't solve it like an equation. So to find the answer for the quadratic inequalities, we have to draw the quadratic curve. Okay, this is a U-shaped curve. It's a U-shaped curve because the coefficients of x squared is 1. Right, so it's a U-shaped curve, and the two x-intercept are 1 and 2. How do you find the x-intercept? That is when you let this linear factor x minus 1 equal to 0, you get x equals to 1, which is the first x-intercept. And then you let x minus 2 equals to 0. So x equals 2 will be the second x-intercept. Alright, so to find the range of values of x, we need to look at the portions that we want for your values of y. Now your x-axis is y equals to 0. Okay, so the next thing is that, okay, look at your inequality. We are looking for the values of y to be less than or equal to 0. So which is actually the part of the curve that I've highlighted in yellow. So that is y less than or equal to 0. This part of the curve that I've highlighted is y less than or equal to 0. So the corresponding values of x will come from the x-axis, which is the one I highlighted in blue. Oh wait, so I need to erase off this thing. Okay, so the answers will come from the highlighted, the blue zone, which is between 1 and 2 inclusive. Right, and the next thing is that we want to represent this. This is our answer, right? But we need to represent it on the number line, so it's pretty easy. Just draw I use a ruler to draw a line, and then make sure that there's arrow at the end, and then indicate the two endpoints, which is 1 and 2. Okay, we're using solid circle here because it's including and also inclusive of 2, the two endpoints. Alright, so this is how we solve question 1. Alright, so for question 2, the concept is the same. Alright, find the range of values of x to solve the quadratic inequalities, except this question is slightly harder than the earlier one. You will need to do more expansion, more algebraic manipulations. Okay, so we need to use a distributive law, right? I'm using distributive law to expand the two terms there on the left and on the right, and then simplify it further, bring everything to the left hand side. Okay, simplify some more, and then you end up getting a quadratic inequalities, x squared minus 4. So x squared minus 4, if you were to recall, right, you can use this algebraic identity a squared minus b squared to factorize it. That will give you a minus b times a plus b. So you factorize it into x plus 2 and x minus 2. Okay, the coefficients of x squared is 1, is a positive value. So we are talking about a U-shaped curve again, right? So let's draw a U-shaped curve. Identify the two x-intercept, which is negative 2 and 2. Oh, it's negative 2 and 2, not this one here. Don't have. It's supposed to be negative 2 and 2. Wait, I should just change this. Yeah. Okay, it's negative 2 and positive 2. Alright, the next thing is to identify the region that you want. Right, so it's a y less than or equal than 0. Then the corresponding values of x, which will come from the x-axis. So it's between negative 2 to 2 inclusive. Okay, with that, we need to draw the number line. And then solid circle because it's inclusive of the two endpoints. So you see that this question is the concept is similar to 1a, except that you have more algebraic manipulations to be done here. Okay, so let's look at the next question. So the next questions, yes, if you look at this quadratic inequality, we can actually factorize 4 out because there's a common factor 4 there. Oh yes, and before that, of course, I'm using this algebraic identity, a squared minus b squared, to factorize it. Okay, so first thing first is to factorize your 4 out. And then divide by 4 on both sides. So dividing by 4 by a positive number will not change the inequality sign. Now, I always like to use a U-shaped curve so that you can just remember one type of curve. You see, you don't have to remember N-shape, U-shape. Just remember one type of curve that's U-shaped. So to make it U-shaped, I need to multiply. I need to make the coefficients of p squared 1. Positive, sorry, not 1. Make the coefficients of p squared positive. Right now, it's actually negative. So I need to multiply both sides of the inequality with negative 1. And if I do that, I have to flip the inequality sign. Okay, if you're multiplying both sides of inequality with a negative number, you need to change the inequality sign. Okay, so we're going to rearrange it. Instead of writing negative 4 plus p squared, you can write it as p squared minus 4. Factorize it using your algebraic identity. So now you know that it is a U-shaped curve because the coefficients of p squared now become positive 1. So we have a U-shaped curve drawn already. The two x-intercept will be negative 2 and 2. Okay, that's where you let the linear factor p plus 2 equals to 0 to find your p-intercept. Oh, sorry, this is in terms of p, not x. Then you let p minus 2 equals to 0 to find the other p-intercept. So your p-intercepts are negative 2 and 2. Okay, identify the region that you're interested in, which is strictly y less than 0. And then the corresponding values of x that will come from your x-axis, which is the one highlighted in blue. So it's between negative 2 to 2. All right, not inclusive of negative 2 and 2. Right, so in this question, we are not asked to draw the number line. But if you're asked to draw the number line, this is how you do it. Okay, just use the ruler, draw a line, and then mark your two endpoints. And here you have to use empty circle because it's not inclusive of negative 2 and 2. So you use empty circle to represent it. So this is how you do it if you need to use to represent your answer using a number line. Alright, so the next question is to perform completing the square skill. Right, so you're given a quadratic curve, and you need to complete the square for it. Alright, so we're going to rewrite it as ax squared plus bx plus c. So it becomes negative 2x squared plus 4x plus 5. So to perform completing the square, okay, step number 1 is to make the coefficients x squared to be 1. So we need to factorize negative 2 out. Okay, and then the next step, it's by now you should know how to do completing the square. Take the coefficients of x, which is negative 2, divide by 2. Alright, square it. Okay, you add and you take away. Now, I keep mentioning the importance of putting your square bracket here. Okay, the square bracket is very important. You must have it there. So the next step is to, oh yeah, I'll show you how I get negative 2 there. That is to take the original value, which is 4x, divide by negative 2, divide by the number that, the common factor, which is negative 2. So 4x divided by negative 2 gives you negative 2x. So that explains the blue highlighted portion there. Okay, so the next step is, yeah, these three terms here, sorry, these three terms here, okay, will collapse into this guy here. Okay, and this you can just work it out. What gives you negative 2 divided by 2 is negative 1. Negative 1 times negative 1 gives you 1. Let's explain how you get the 1 there. Okay, the square bracket remains there. Very important, square brackets remain there. The next step is to multiply a negative 2 into the square bracket. Okay, And why do I get a positive here is when you take negative times a negative, get a positive. Okay, so this is, but you have to rearrange it in this form. Okay, rearrange it in this form, where you need to write the constant first, 7 first, followed by your completed square. Okay, so right, so if you look at this, coefficients of x squared is negative, so it's an n-shaped curve. N-shaped curve, you will have maximum value. Okay, it's an n-shaped curve this way, so hence you'll be given a maximum value. All right, so to help you find the maximum value, let's write down the maximum point. So maximum point is 1,7, and from there we know that the maximum value of y is 7 and the corresponding value of x is 1. Okay, so this is another it's similar similar in nature to what we have done early on. Okay, so rearrange it as minus 2x squared plus x plus 3, factorize negative 2 out. Alright, so the coefficients of x is 1, so we take 1 divided by negative 2. So that's explain how I get the highlighted, how I get this guy here, how I get negative half x here. Okay, right. And then the next thing is that perform completing the square, take the coefficients of x, which is negative half. So negative half you divide by 2 will gives you negative 1/4. Okay, so you square it, so you add and then you take away. Then the next step is this, make sure that the square bracket is there. Square bracket is very important, not to forget your square bracket. So these 3 terms here will collapse into this. And then this one here, you can use your calculator to work it out to get 1/16. The next step is make sure negative with negative will give you positive. Simplify further and you get that as the answer. Okay, right. So here you asked to find, in the questions it says that you need to find the values of a, h, and k. Right, so you need to compare your answer with what is given. Right, what is given here, need to compare with what is given here. And from there you can find your a to be negative 2, your h to be negative 4, and the values for k is 3, 1/8. Alright, so the concept is the same, but the questions are phrased slightly differently from what we have done earlier on. Right, so part 2 is slightly more challenging. If you look at part 2, right, hence, when you say hence means you need to make use of the answer that you have gotten in 2a part I. Right, so what is the answer we have gotten? Gotten. What is the answer we have found in 2a part I? Right, so this is the answer we have found earlier on. So we need to make use of this answer. So from this answer, okay, you will see that yes, so we need to find the range of values of c such that this equation has real and distinct roots. So what this guy here means is, what this one here means is that I have a curve, and then I have a line. Okay, I have a line, because if you're going to replace your 3 plus x minus 2x squared with y, okay, wait, hang on, with y. So what we are saying is that we're actually finding the intersection point of a curve. So this is a curve, right? This one is a curve and a horizontal line, y equals to c. Okay, so it's something like this. Okay, I want to find how should this line behave? How should this line y equals to c behave such that it will intersect such that it will intersect the curve and give you distinct roots. So if you look at what I've drawn for you, it can be like that. If the line is above the curve, then there's no roots at all, no intersection point. But if it's in this way, then that's only one root. But the question says distinct roots. Distinct roots means more than one. So it has to be in this way, right? Okay. So how can we make use of the answer from part 1? So from part 1, we know that the maximum point for y is 3 1/8. That's the maximum point. This guy is your maximum value. Not point, sorry, maximum value. 3 1/8 is the maximum value for y. So therefore, in order to have distinct roots means you must have two intersection points. So to have two intersection points, then how would your y equals to c looks like? The horizontal line, right? Your horizontal line will have to make sure that it cuts the curve at 2 points, right? And to do that, the values of c has to be below 3/1/8, right? Okay, so this is another kind of questions that you may encounter, right? But the concept is the same. Part one is always the same. That is, you need to apply completing the square, right? So completing the square is actually a very useful skill for you to find maximum or minimum values, corresponding values of x, and then so in this question here, first part one, again, it's just to perform completing the square, factorize your 4 to make coefficients of x squared be 1. Okay, and then so on and so forth. Okay, this part here I won't need to explain again. By now you should be able to do it very well. Okay, and then make sure the square bracket is there. Okay, right. So here we're dealing with a U-shaped curve, right? U-shaped curve. We are not also asked to find the values of a, h, and k. You're just told that a, h, and k are constant. So we just leave our answer as this. So this is the answer for part 1. So for part 2, you're asked to find all possible real values of x. Okay, so the explanation is already there on the screen. Okay, so we observe that, right, when you square something, it's always more than equal than 0. If you multiply by 4, it's also always more than equal than 0, because 0 times 4 will give you 0, right? It times 4 here. And then if you take away negative, take away 29 on both sides. So you see that the minimum, sorry, this is a U-shaped curve. So the minimum values for fx will be negative 29. So if I'm going to draw the curve for you to understand better, this is what it means here. Okay, so your minimum point is 3 and negative 29. So therefore, all possible values of fx refer, okay, wait, let me draw the curve properly for you with the x-axis and the y-axis. Okay, so this on the x-axis is labeled as x, on the y-axis is labeled as f of x. So your is the curve will be like that. Okay, so your minimum point, your minimum value, your minimum point here it's 3, negative 29. So your minimum value here is negative 29. So therefore your fx value is just referring to the y value. So your y value will be anything more than or equal than negative 29. So this is what it means. Okay, all possible real values of fx, it will be more than or equal than 29. It will be this portion here and this portion, and you see that that portion, the f-axis, will always be more than or equal than negative 29, because negative 29 is a minimum fx value already. Okay, so this is a questions you need to show that the roots of equations are real. So we need to show, we need to prove lah, to show lah, to explain lah, we have to go find values of b squared minus 4ac. We need to go and find the values for b squared minus 4ac. So first thing first is we write down the values for, write down your quadratic equation, the values for a, b, and c, so we can plug into your b squared minus 4ac. And then what I have here is I use this algebraic identity to expand it. Alright, so I will get this quadratic expression, and then I will use the cross method here to factorize it. Okay, then you observe that what I'm getting is actually two linear factors. They are the same. So you can actually just stack it up. Right. Okay, so we need to do some explanation. So what are the explanations? So the explanation is that, note that yes, when you square something, is always more than equal than 0. So therefore, your b squared minus 4ac will be more than equal than 0. Because this value, where does this value come from? This value come from this guy here, right? So if this value is more than equal than 0, we are saying that b squared minus 4ac is also more than equal than 0. And what does it mean? Hence the roots are real. Okay, for all real values of x. P and Q. So this is how you do showing or proving or explaining question. Okay, we can apply the same concept as what we have done earlier on, right? So if you find that if you look at all these questions are similar in nature, so you just need to find out how to do one or two questions, understand the concepts, and then you find that you can actually solve a lot of similar questions. Okay, so yes, find the values for b squared minus 4ac. All right, and then simplify it. But in this case here, you realize that you can't really expand it. You can't really factorize it using the cross method. All right, you won't get a perfect square like what we have done earlier. Earlier on, when you use the cross method, you get perfect square. Here, you need to apply completing the square. Right, so for these two chapters, right, completing the square, it's a very important skill that you must use, you must master. Okay, so from there you complete the square and you will get this answer. So we need to do some explanation again. So what is explanations that we can go? All right, we always start with the square of something always more than equal than 0. You add 4 to both sides, you still be more than 0. So therefore b squared minus 4ac is more than 0. And what does b squared minus 4ac more than 0 tells you about the roots? Yes, the roots, the equations has real and distinct roots. Okay, so we're going to do another similar kind of questions, except it's a bit more challenging because why? You need to do more algebraic manipulations, but the skills are still the same. Find the values for b squared minus 4ac. So it's either you can factorize it using the cross method. If you cannot factorize using the cross method, then you have to use completing the square. So there's only two methods you can use, okay? Factorize using cross or completing the square. And then after you have done the factorization, or the next step is to do explanation. And for explanation, we always start with this guy. Start with something squared. Okay, that will always be positive, more than equal than 0. We add 8 to both sides. It will be more than equal than 8. Of course, 8 is more than 0. So therefore, b squared minus 4ac is more than 0. And therefore, the equation has real roots for all real values of k. Okay, this is how we do it. All right, so what is the concept involving here? The concept involving here is that a line meeting a curve. So when you meet someone, you can meet at one point or you can meet at 2 points. So if you combine both of them together, okay, first of all, you need to find equations in terms of x first. All right, and then if you combine both of them together, what we are saying is that the values for b squared minus 4ac must be more than or equal than 0. Here you can use the value of b squared minus 4ac more than or equal than 0, because here the questions, this is not a question to show or to prove or to explain. Here the questions literally tell you that the line meets the curve. Is a fixed information, so you can just use it. You can just use b squared minus 4ac. Yes, you combine both of them, you get b squared minus 4ac more than equal than 0. You plug in the values for b, a, and c. Alright, you end up getting a quadratic inequality. Okay, right. So again, I would like to convert it into a U-shaped curve. So I multiply both sides by a negative number. So you need to flip the inequality sign. Okay, very important. When you multiply something with a negative for inequality, you need to flip the inequality sign. Okay, factorize it. A squared minus b squared is a plus b, a minus b. Draw your quadratic curve. Identify your two k-intercept, which is negative 3 and 3. All right, and then the corresponding values. Oh, okay, I found a mistake here. This guy is not x, this is supposed to be k. So is k greater or equal than negative 3, less than or equal than 3. Okay, so that's the answer. All right, so the concept here is, what's the concept here? Does not intersect the curve. The line does not intercept the curve, so it means there's no real roots. Means the value for b squared minus 4ac is strictly less than 0. So, right, as usual, form of equations in terms of x. Okay, write down the values for a, b, and c. Right, sub into your b squared minus 4ac less than 0. Okay, you end up getting p squared minus 16, where you can factorize it into p minus 4 times p plus 4. This is a U-shaped curve. Draw your U-shaped curve. Identify your two px intercept. Is p, not x. 2p two p-intercept, not x-intercept, p-intercept, which is negative 4 and 4. Identify the region you're interested in. Identify the corresponding values of x, which come from the p-axis. So it's between negative 4 and 4. So that's the answer. Alright, so the concept here is the line is a tangent. So what do you mean by the line is a tangent? So the line is a tangent means the line cuts the point at only one point, that you have two real and equal roots. And what is the concept involved here means the value for b squared minus 4ac is equal to 0. So same thing, form of equations in terms of x. Write down the values for a, b, and c, sub into your b squared minus 4ac equals to 0. In this case here, we are dealing with the equation, so it's much easier. It's not the quadratic inequality, you're just solving it, so it's very easy. Okay, factorize, divide 48 with 16, that gives you k squared equals to 3. So k is positive or negative square root 3. It's a cert. Alright, so for question 5, it's just solving two equations simultaneously using a substitution method. Okay, so this one is quite easy. I'm going to go through quite fast. Make x the subject from first equation, substitute into your second equations. Okay, right. The only thing you need to take note is when you factorize this, not factorize, oh my god, expand. When you expand this one, make sure you expand it using this algebraic identity. Okay, make sure you expand it properly. Alright, correctly, not properly. Make sure you expand it correctly, otherwise you won't get your answer. Simplify it. Okay, factorize it. Find the values for y, and that's not the end. You have to go on to find the values for x. Alright, and the next thing is that you must present your answer correctly. Your answer asks for the coordinates of points of intersections. So you have to present it as point form. So what does point form means? This is what I mean. Okay, you have to present your answer as point form, x coordinate, comma, y coordinate. Okay, so this one again is not difficult. Just make x the subject from equation 1, substitute into the second equations. Alright, again, very important is to make sure that you expand this guy correctly using the algebraic identity. Alright, and be careful with all the manipulations. Alright, simplify, simplify, simplify. End up with a quadratic equations, and you can just factorize it into two linear factors. Okay, and we don't stop there. You still have to go on to find the values of x. So substitute into equation 1 to get values of x. Alright, so there are 2 points of intersection, so you have to present it in point form. Okay, finally, we've come to the last question, but this one is more difficult. It's more algebraic manipulation. It's more algebraic manipulation is more challenging than question 5 and 5a. Okay, so you have to be very careful while doing it. Best is that you make y the subject. You can make x a subject, but you have more things to work on. So I think it's easier to make y the subject here. Okay, it will be in terms of fraction. So write it as 11 over 3 minus 4x over 3. It's easier. Just write it as two separate fraction easier. Substitute one into your into your the curves there. Alright, and then you have to expand it very carefully using your algebraic identity, and you see that I actually make this as a fraction. 25, I write 25 as 25 over 1, write 5x squared as 5x squared over 1, because just to make everything as fractions is easier to manipulate. Okay, so the next thing is that you can see that I actually multiply by 9 throughout, because your denominator, if you look at the denominator, all this denominator, right, this guy, this guy, this guy, this guy, this guy, the LCM of 3 and 9 is 9, so you multiply by 9 throughout, and you end up getting this complicated thing there. But not to worry, you can just use your calculator to help you simplify into a very beautiful, very beautiful quadratic equations, where you can really just factorize it using either your calculator or using the cross method. You can factorize it beautifully. Okay, so you have 2x intercept, then you have to substitute into the equations that you have formed earlier on to find your y, 2x intercept, to find your y coordinates. Okay, and then you need to present your answer as points, coordinates of points of intersection, so as point form. Okay, right. So finally, we come to the end of your revision package. Okay, so please do your best.